This vector video is going to be about the coordinate system and component vectors. So a lot of times when we talk about vectors, we talk about people moving or forces being applied in specific directions. And so we can talk about that on a graph coordinate system. So let's say you have your x and y axes. These can also be related to general directions, where generally the positive y-axis is north, the positive x-axis is east, the negative y-axis is south, and the negative x-axis is west, like map directions. They can also be related to angles, and generally I like to refer to them as angles starting from the positive x-axis going counterclockwise. So the positive x-axis would be a 0-degree angle. North would be 90 degrees. West would be 180 degrees. South would be 270 degrees. So for example, if we were to draw that Mark walked south 5 meters, that vector on a coordinate system would be directly south, where the beginning part of the vector is at the origin and the ending part goes 5 meters south. And we can write that this is 5 meters. And the direction is implied in the direction of the vector. In this case, Mark walks 5 meters 60 degrees north of west. So if we draw our coordinate system and we think to ourselves, okay, if this is east, this is north, this is west, and this is south, if Mark is going 60 degrees north of west, that means we're starting west and going north of there. And 60 degrees north of west will put us something like this, where this is, we start at west and we go, we start at west and we go 60 degrees north of west. You can also find, you can leave it like that. I personally like to find the angle, again, from the positive x-axis counterclockwise, so that angle would either be the 180 minus 60 or the 90 in this quadrant plus the extra 30 here. And either way you get 120 degrees. So let's think about vectors in this way. If you have a vector on a coordinate system, I'm going to focus mostly on the first quadrant here. Let's say you have a vector A. You could agree that vector A can be discussed merely in both the magnitude and direction of vector A as it is. We can also talk about vector A as the sum of two other vectors, its component vectors, the things that make up the component parts of A. And we'll have two component vectors for A. We can have the vector of A in the x direction along the x-axis. So that's the amount that A goes horizontally in one direction. And we can also have the vector that shows the amount that A goes in the y direction. And so we can write this as that vector A is the sum of A sub x, the A component in the x direction, and A sub y, the component of A in the y direction. And if we did add these together, we would get A. and it would give us the appropriate direction. And this is particularly nice when we start talking about adding vectors, because we now have a perfect right triangle, and we can use Pythagorean theorem to solve for A or for any of the other quantities here. But we can write out that A squared is equal to its x component squared added to its y component squared. Right? And we can use if this is an angle theta, we can use some principles of basic trigonometry, namely SOHCAHTOA, to do things with theta. For example, we could say that sine theta is equal to the opposite, which in this case is a sub y, over the hypotenuse, which is a value of a. We can say cosine theta is equal to the adjacent over, the adjacent is the a sub x over a. And tangent of theta is equal to a sub y over a sub x. And if we rework these, they also become useful in finding values. Let's say we know the angle, right? A lot of times when we have vectors, we're like, oh, we're going like in our last problem here. We went 60 degrees north of west, so I already know my angle of my vector, but I don't know my components. I can rework these so that I can find my component vectors, where I can say a sine theta is equal to a sub y. A cosine theta is equal to a sub x. Okay, so both of those are going to let us find our component vectors. Now let's say we have those, but we're trying to find theta. A useful way to do that is using our tangent, where we can do the theta, if we're trying to find theta, is going to be equal to the inverse tangent of a sub y over a sub x. And we will do an example problem in the next video.